Okay, so what's up? So today we will be looking at my source code, my answer in this particular kata. So square matrix multiplication. Okay, so essentially we will be multiplying the row of the first matrix to the column of the second matrix. So for example, we will be multiplying this row to this first column and then second column. And then the answer for that is this 5 and 4. So 1 times 3 plus 2 times 1 is equals to 5. Then 1 times 2 plus 2 times 1 is equals to 4. And then this row here will be multiplying with these two columns here. So 3 times, so this row with this first column. So 3 times 3 plus 2 times 1 is equals to 11. And then 3 times 2 is equals to 6 plus 2 times 1 is equals to 2. Then overall it's 8. Okay, so our answer will be on the shape. It's a two-dimensional. Same shape with this two matrix. Okay, so I have two solutions here. And then this is my initial submission for this kata. So train. So I already submitted it, and I'm just making a video for you to show my source code. Okay, so this one is nested for loop, three-dimensional for loops, and both of these answers can be converted into one-liner. So later in the video I will show you how to convert this in one line, okay, using list comprehensions. So in this first on my first solution, so I initialize my output. So it's a list. So empty list, and then I also initialize the row count. So this will represent this one, row count. Okay, so because we need to access each row in element A, so each row will be multiplied in each column in B. Okay. Next is row length. So basically this is the row length. What is this? So I think this one. This corresponds for B, the row length. So since it is a square matrix, so we can also use the length of A. Okay, so row length and row count. So in this function, so what I did is I am what is I'm getting the current row and current column. So current row, and then I will multiply it with these two columns. Okay. So that is the first for loop. So it corresponds for each row for A. Okay. And then row values, this will contain all the summation, the sums. Okay. And then I also made a for loop for B column. So this corresponds for each column in B. Okay. So that I can get each columns in matrix B. So current row is equals to A index row. So it will be based on this one. So if you print this, print row, print current row. So print current row. So this row will be printed twice, and then this row also will be printed twice. Okay. So it must be printed twice, or because this row must be multiplied with each column. So these columns will be there will be two columns. Okay. Next, current row, current column. So if we print the current column, should be, so this will be printed column 1, column 2, and then column 1, column 2. Let's see. Okay, 3 1 2 1, then 3 1 2 1. And then I made a for loop with zip function so that I can access the two lists at the same time. And then so I use list comprehensions for getting the columns, and then for multiplying each element and then summing it up. Okay, value. And then I appended the value. So this value is the single value to this row values. Okay. And then this row values, so it's a list, we will be appending it to our output. Okay, so like this one. We will be appending this to our output. So this will be our output list, and then this will be our row values list. Okay, and then we will just return the output. So let's try it. So with these two sample matrix A and B, so this must be the answer: 5 4 11 and 8. So 5 4 11 and 8. Okay, so this function or this whole code can be converted into Oneliner. So let's give it a try. So of course we will be using a list comprehensions. We will start on the inner for loop. So current row. So we'll be copying this one and then this one. Okay. And then value is equals to this one. So we can replace this. And then we will be having this row B, a row length, so it's the same. So we can copy this one there here, and then row count is equals to this one, and then output, we will be needing this one, and then row values that append. Okay, this one. So you guys must know list comprehensions. So list comprehensions enables us to have a one-liner for loops, shorthand for loops, row values. Okay, so it's the same with this one. And then this for loop, we'll insert this with output, and then copy this one, and then we'll just return the output. Okay, so let's give it a try. Let's make this a comment. So Python main.py indentation error 54. Oh, okay. So we need to comment that also. So 5 4 11 8. Okay. So on my next solution, so I'm using a nested for loops, though it's also a nested for loop on the first solution. So we have an output for row. So basically this for loop will be handling this rows in A, matrix A, and then row index and column index is that we need to access both row and column, row in A and column in B. So we need two for loops for that. So if you will use one for loop, so it's impossible. Okay, so row values will also contain the values for each row. Okay, I think this one, the summation for each row, the values, and we're just appending this multiplication. Okay, so this will be For this one, column index, and then this one. So let's try. So Python main.py 511. Okay. And we can also convert this into one-liner. So let's try it. So first one, we will be starting at the innermost for loop. So for call index, and then append row values that append this one. Okay. And then row values is equals to this one. Okay. And then this for loop for row sum, and then we will append this one. Okay. And then output row sum. Okay, so I'll just copy this one for loop, and then row sum, I think. Okay. And then we'll just return the output. So one-liners in Python. Okay, so Python main.py. Okay. So let's give it a try. First one. Okay, let's submit the two one-liner. So test. Let's see the time it took. So attempt for the attempt. So time is 853 milliseconds for 53 test cases. Okay, so it's not limited in 2 by 2 arrays. So we have 10 by 10, 7 by 7. Okay, so the maximum will is 10 by 10. Okay, so 853 millisecond for the first function, our first solution. And then for this one, so test, and then attempt. 853. Okay, so so the second function or our second solution is faster than the first. So submit. Okay, that's it for our square matrix multiplication. Okay, so from other players, they used NumPy, and so it can be, but I don't want to use NumPy because in NumPy there is a matmul function that automatically multiplies to matrix. So that's it.